In this video, we're going to talk about how to calculate the mass percent of a solution. So here we have 15 grams of sodium chloride dissolved in 225 grams of water. What is the mass percent of sodium chloride in a solution? Now first, you need to understand the difference between the solute and the solvent. In this case, the solute is sodium chloride. The solvent is water. The solvent dissolves the solute, so water dissolves sodium chloride. Combined, this makes the solution. Now the mass percent is the mass of the solute divided by the mass of the solution times 100%. So in this example, we have the mass of the solute. We have 15 grams of sodium chloride. Now the mass of the solution is the sum of the solute and the solvent. So it's 15 plus 225, which is 240. And then we got to take that result multiplied by 100%. And that will give us the mass percent of sodium chloride in the solution. So it's 15 divided by 240 multiplied by 100%. So in this example, the mass percent is 6.25% of NaCl. Now let's move on to number 2. 25 milliliters of methanol is mixed with 150 milliliters of ethanol. What is the mass percent of methanol in the solution? And what is the volume percent of methanol? Well, let's focus on the volume percent first because it's a lot easier to find. The volume percent is very similar to the mass percent. You're just dealing with volume. So it's going to be the volume of the solute divided by the volume of solution times 100%. So what's the solute in this example? Well, in this case, the solute is going to be methanol because we have a lot less of methanol than ethanol. So the methanol is going to be dissolved by ethanol since typically the solvent usually exists in greater quantity. So we have 25 milliliters of solute, and the solution is the sum of the solute and the solvent. So 25 plus 150, so we have a total volume of 175. So the volume percent is 14.3% by volume of methanol. So that's the answer to the second part of the problem. Now let's focus on the first part. So we have the volume and the density. We can use that to calculate mass. Now we know that density is mass divided by volume. So if we multiply both sides by the volume, density times volume is equal to the mass. So let's calculate the mass of methanol first. We have 25 milliliters of methanol, and the density is 0.792 grams. Now it's important to understand that 1 cubic centimeter is equivalent to a milliliter. So this is basically grams per milliliter. And now these units will cancel. So 25 times 0.792, that means that we have 19.8 grams of methanol, which is CH3OH. Now let's calculate the mass of ethanol. So the volume is 150 milliliters, and the density is 0.789 grams per milliliter. And so we could cancel milliliters again. So if we multiply those two numbers, that is going to be 118.35 grams of ethanol. I'm going to write it as CH3, CH2, OH. So now we can calculate the mass percent. So the mass percent is going to be the mass of the solute, which is methanol in this example, is 19.8, divided by the mass of the solution, which is the sum of these two numbers. So 118.35 plus 19.8. So we have 138.15 grams of solution. Alright, so let's go ahead and put this in a calculator. So the mass percent is 14.3%. The mass percent is very close to the volume percent because the density of these two are almost equivalent. Now let's work on number 3. The density of a 0.75 molar sodium hydroxide solution is 1.1 grams per milliliter. Calculate the mass percent of sodium hydroxide in the solution. So how can we do this? How can we take the molarity and the density of the solution to find the mass percent? We really need to find two things, the mass of the solute and the mass of the solution, in order to get the mass percent. So how can we do that? So if you want to try this problem, feel free to pause the video and see what ideas you can come up with to get the mass percent from density and molarity. Now you need to understand that the molarity represents the moles of solute per liter of solution, and the density is the grams of solution per milliliter of solution. Now, I think it's helpful if you select a volume for the solution. The best volume to select is 1 liter. So in a 1 liter solution, we can calculate how many moles are in this solution. The molarity is 0.75, so that means there's 0.75 moles of sodium hydroxide per 1 liter of solution. You can select any volume. It could be 500 milliliters, 10 liters. It will still work, but I think it's best if you select 1 liter. Now we can convert moles into grams. So we need to find the molar mass of sodium hydroxide. So that's Na plus O plus H. The atomic mass of sodium is approximately 23, oxygen is 16, and hydrogen is approximately 1. So there's 40 grams of sodium hydroxide per 1 mole of NaOH. And so this will give us the mass of NaOH. So it's just 0.75 times 40. So in a 1 liter solution, there is 30 grams of sodium hydroxide. So now we need to find the mass of the solution, and we have to use the same volume. So let's start with a 1 liter solution, and let's convert it to milliliters. There's 1,000 milliliters per 1 liter of solution. And now we can convert milliliters to grams using the density of the solution, which we know to be 1.1 grams per milliliter of solution. So this is 1,000 times 1.1, so there's 1,100 grams of solution. So now that we have the mass of the solute and the mass of the solution, we can now find the mass percent of the solution. So it's going to be the mass of the solute, which is 30 grams, divided by the total mass, which is the same as the mass of the solution, that's 1,100 grams, multiplied by 100%. So 30 divided by 1,100 times 100. This is about 2.73%. So now you know how to calculate the mass percent of a solution if you're given the density and the molarity of the solution. So choose a volume and then use that volume to calculate the mass of the solute and the mass of the solution, and then you'll find the mass percent of the solution.